Good morning, professors, TA, and fellow students. We are Group 13, and today we are excited to present our final project, the Student Course Selection and Credit Management System. Our team members are Lin Binyi, Wu Yulai, and Hou Zhongchen. Our project, as the title suggests, we aim to develop a system that assists students in more effectively planning their course selection and managing their extracurricular throughout their university life, ultimately helping them achieve a better balance between academics and personal development. In our university experience, we've observed several common challenges that many students, including ourselves, often face. Firstly, many students tend to participate in too many courses and extracurricular. University life offers a wealth of opportunities from academic courses to diverse club activities, all of which are very appealing. However, sometimes due to a wide range of interests or an inability to prioritize, we can't overcome it. This often leads to the second point, poor time management and planning. When the pressure from both coursework and activities becomes overwhelming, a lack of good time management skills can easily make one feel disorganized and unable to allocate energy effectively. Ultimately, this situation can result in the third issue, a declining of academic performance. When time and energy are overly dispersed, academic results can suffer, which is a scenario we all want to avoid. Therefore, our student course selection and credit management system incorporates three core features designed to effectively tackle the problems we just outlined. First of all, course time estimation. This system will help us estimate the time commitment required for each course, allowing students to have a clear understanding of the future academic workload when selecting courses. Second, extracurricular integration. We don't just focus on academics, we've also integrated the planning of extracurricular into the system. Students can log their involvement in clubs and other activities, along with the estimated time they plan to dedicate, enable the system to consider these in the overall plan. Thirdly, weekly plan generation. This is one of the cornerstone functionalities of our system. It generates a recommended weekly schedule for academic study and activities, based on the students' chosen courses, activities participation, desired grade outcomes, and even their current skill level relevant to the courses. We'll dive into the database design of our project. Our system primarily revolves around 5 core database tables. First of all is the course database. This table stores detailed information about all courses offered by the school, such as course ID, name, credits, and instructor. This forms the foundation for student course selection. Second, the club database. This is used to store information related to all student club and extracurricular, including club names, activity time, and their nature, helping to integrate students' extracurricular lives. Third, the ability database. This is a rather unique table that stores various abilities a student might possess, like programming, foreign language communication, or presentation skills, along with a self-assessed proficiency level. This design facilitates the subsequent mapping of courses to skill enhancement. Fourth, the performance database. This table records students' historical academic performance data, including IDs of courses taken, courses name, and final grade. This helps students track their learning progress and can serve as a reference for future system recommendation. And fifth, the time plan database. This table stores the weekly study plans and course scheduling and fit the time plan database. This table stores the weekly study plans and course schedules automatically generated by the system, which is the core output of our weekly plan generation features. In a video demonstration that follows, we will further illustrate the relations between this table using an ERD, explaining how we ensured our database design meets BCNF and show how SQL commands are utilized to implement the system functionalities. Okay, now let's introduce the first main function of our system course planning. The implementation of this and subsequent functions relies heavily on precise SQL queries and operations on our backend database. Now let's introduce the first main function of our system, student course planning. The implementation of this and subsequent functions relies heavily on precise SQL queries and operations on our backend database. Before each semester or during the course selection period, students can use our system to plan the courses they wish to take. Specifically, students can browse or search for available courses for the semester. For courses they are interested in, they can add them to their personal course list. Concurrently, for each selected course, students can input their expected score and estimated weekly time commitment. These two pieces of information are vital for generating a personalized time plan later on. The system will then automatically calculate and display the total credits for the current selected courses, helping students keep track of their academic load. This feature is designed to give students an initial assessment of their semester workload right from the course selection stage. Okay, next up is our second main function, ability assessment and mapping. We believe that university is not just about acquiring knowledge, but also about enhancing various skills. The concept behind this function is as follows. We built a platform where students can, before the semester begins or at any time, define a various ability they currently possess, such as presentation skill, programming, or teamwork. For each ability, student can set a numerical proficiency level. For example, on a scale of 1 to 5. Allowing them to quantitatively assess their current skill set. Simultaneously, in our course database, each course will be tagged with the relevant abilities. It's primarily aimed to improve or train. And through this function, we aim to help students more consciously connect their course learning with their personal skill development. Our third and perhaps most distinctive main function is the weekly time plan. The function comprehensively considers several factors: the credit hours of the courses a student is taking, the time spent on extracurricular activities, the expected score set by the students for each course, which indirectly reflects their willingness to invest effort, and the student's ability level related to the courses. For instance, if a skill is weaker, more time might be needed. And based on this input, our system automatically generates a suggested weekly time allocation plan for both academic work and extracurricular. This plan helps students to clearly visualize how their week is distributed, thereby enable them to better balance their studies, club activities, and personal lives. And to avoid time conflict or excessive stress. and to avoid time conflict or excessive stress. You will see this function in action in the upcoming system demonstration video. Next, we'll briefly describe the system architecture of our project. As shown in the diagram, our system employs a common three-tiered architecture. Next, we'll briefly describe the system architecture of our project. As shown in the diagram, our system employs a common three-tiered architecture. The front end, which is the user interface for interacting with the system, is developed using Vue.js, a modern JavaScript framework, to provide a responsive and user-friendly experience. The backend is responsible for handling all business logic, API requests, and database interaction. We chose Node.js with the Express.js framework for this layer. Within the backend, we have further structured it into controllers to handle specific business logic, roles to define API endpoints that receive front-end requests, and dispatch them to the appropriate controller, and routes to define API endpoints that receive front-end requests and dispatch them to the appropriate controller, and a database interface that manages the actual connection and SQL operation with the database. Finally, the database itself, serving as a core data storage, is MySQL. This is a mature and widely used relational database management system where all our course data, students' information, abilities, and time plans are stored and managed via SQL command from the backend. This architecture ensures a separation of concerns between the front-end and back-end, enhancing the system maintainability and scalability. Architecture ensures a separation of concerns between the front-end and back-end, enhancing the system's maintainability and scalability. After all this explanation, we now come to the most crucial part of our project, the system demonstration. Okay, here comes our system demo. So first of all, you have to register a user. So click the register button. And here we can enter our student ID and password. And here I'll use my student ID and password, and enter my name, Okay, and my major and my weekly available hours, maybe 14. Then click the send button. Yeah. Then enter what I have registered. And we can log in the system. Okay. So here comes the dashboard of our page. And this is our developing team. And here are three guys, and I'm the center of our team. And this is Wu Yulai, and this is Hou Zongchen. And then we dive into the functionalities of our system. So first of all is the course selection. So you can see all of the courses recorded in our NCCU course selection system, and we can click one of them and enter your expected grade, maybe 95, and we send and another course. How about some data structure, and how about 100, and also the commerce law, This I think I only need 18. Okay, so next we move to the abilities, and from here you can choose some abilities that you think you might have, and you can give yourself some ability level. And I think I have a poor time management, so I give myself 2. And okay, and next one, I think I just know a little bit about sequels, so maybe I just give me 1. Okay, so and how about another one is the creativity, and I give myself 5 points. And here comes my abilities. As you can see, I have chosen 3 abilities, and here comes the abilities. And the next one is my extracurricular, and for this semester I have joined nope. For this semester I have joined the judo club and yeah, only judo club. Okay, so you can select what you have joined this semester, and yep, and then it goes to here, and you can see. And the next one is our performance. That's what the class we have took, the course we have taken in a previous semester. So I think I have taken the statistic one, and I've got 95 points. And next we click the time plan to see what it have generated, and here we can see an average grade in the previous semester is 95 points, so pretty high, but it's just fake. And it suggests me to read the commerce law 5.05 hours a week, and the database management system needs 9 hours a week, and the data structure also a heavy load. And here's my club activities, and it spends me 6 hours a week, and it's helped me arrange my time that I have to do study for 3 hours and review for 4.7 hours a week. And but actually we haven't finished these functionalities for now, and I think we'll enhance our functionality in the future, and you can log out the system. And for this project we have implemented the agile development. So this is our process. So first of all is on April 7th. Then we finish our product backlog on April 7th. And for our first round of sprint starts from April 8th and end on May 5th. We schedule for 4 weeks, and every day when we have to go to sleep, then we have a stand-up meeting too, and then we can finish our project schedule. Then we have an overall review on May, and we have a retrospective on May 7th. And if we haven't finished something in this round, then we'll move to the next sprint. Okay, so, and this is how our Google Calendar look like. We have so many stand-up meetings every day, 9 p.m. to 10 p.m.